So the way this panel is designed is the topic, as you can see, is democratization of AI resources across talent, across data and models, across infrastructure, and across capital. So the way I will conduct this session is that I will first ask a generic overall macro question from each of the speakers, and I request everybody to be very short in their answers because we have many questions. I'd like to cover all the aspects of this. Then I will come to the talent theme, how we democratize talent. Then I'll come to the data theme. Then I'll come to the infrastructure theme. And finally, I'll come to the capital theme. So we'll try to cover all aspects of the AI ecosystem in a short 25 minutes conversation. So starting the first session, a macro session, and it comes from, starting with you. As AI capabilities are expanding globally, how can governments and industry work together that, the access to the resources, they grow responsibly with security and trust, which are built in from the design itself? How do you do that you mix growth and discipline and safety in a same framework? How do you do that?
I love this question. It's probably one that we can talk about for quite a period of time, but there's a great red clock in the back, and we want to move on that. So I think the key really is, in technology and in security, we talk about roots of trust. If something is built trust from the bottom up, then each layer then builds on that same joint trust. And that's really important from an AI perspective, because in order for AI to be truly transformative, it has to touch different parts of our lives, move at machine speed. So people need to know, what data was a model trained on? Is it data that they trust? What decisions is a model making? What is that? What are the left and right boundaries of what their decisions are? And finally, particularly when we tie to agents, are those agents' identities rooted in role-based access controls and in the kinds of things that work from there? So one of the reasons I love coming to India, and I find it so exciting, is in many ways India has built the foundation for your question, right? When you think about Aadhaar, a national digital identity system, when you think about DPI, a system that allows the API for financial transactions, and then when you build upon that with national data like healthcare data that the government has actually curated, you have the pieces of trust applications in what's the most important, AI that touches lives. Because chatbots are very interesting, but what's really interesting is healthcare in a rural village, Bashini, that allows real-time language translation. So somebody whose native language is not English can hear an advanced lecture in STEM and understand it real-time. Fast enough?
Fantastic, fascinating. So Gokul, that was the strategy point of view. As a practitioner of technology who dirty their hand in actually coding technology, I'd like to ask from you, from a compute and engineering standpoint, what advances are making AI more accessible today than what was possible even 2 years back?
Starts off with what you want to build for what user experience and what workload, because you don't want to start building your technology and then saying go use it, because then you would end up having the same kind of car running on the road. Today you find, the variety of cars, different engine, different sizes, each one using it for different needs. Some for a vacation, some to go into work, some for some other reasons. So heterogeneous compute is one of the key capabilities. So you want to start with what workload, what user experience. Keep that in mind as your architecture. And what I mean by heterogeneous compute is making sure that you can find a way to run it in the most affordable compute capability with the right performance and the right power efficiency. So in this case, it's XPU, as in CPU, GPU, and NPU, depending on where you're deploying it. If it's all on the training and the data center side, it's a different kind of a size and architecture. If it's an edge, it's something else. And if it's at the hands of the end user, it's something else. That's how we look at it. Start with workloads, start with user experience, then figure out what kind of compute you want to give in a scalable, affordable manner with open ecosystem.
Fantastic. Thank you. Kalyan, you are sitting in the mid of the AI in action, AI execution. I'm sure you are dealing with hundreds and thousands of customers in India and abroad. And the often quoted remark is, in B2B space, it is all pilots and POCs and not AI in production. So my question straight, Kalyan, to you is, what is that tipping point when enterprise decides that it's enough of pilot now, I have to go into production now? What is that tipping point an enterprise is looking forward to before this starts, everything starts scaling up?
to start with a very interesting quote someone told me many decades back. God made world in 7 days because he had no installed base. And enterprises sit in a very interesting point, especially in the B2B. We have, for the last 30 years, only added incremental systems, and in a very crude way, I can say we have shoved the dirt under the carpet. So kept on putting carpets, kept on this thing. 15 years back, everyone said, oh, the mainframe will not exist. I think 2% increase in systems hardware on mainframes is an interesting data point, saying that people are not finding better TCO on other systems. They're still sticking to this thing because the applications, the data is being put into significant depth. The tipping point, in my opinion, is we never built systems with the data-first approach. We always built applications, workflows, processes, and the data was hidden behind those systems. The fundamentals of AI is that it needs access to data, independence of data, so data products, having better metadata, definition of data, and then ability to get access to LLMs or SLMs or agents to access them. The reason they struggle to scale is your data stewardship. How do you provide access to data? It's very complex. You can't, to access an employee data, you might think it's just go and query by employee ID. There's so much layers which people have built in the systems. That's where I think orchestration, process intelligence, and then finding the balance between deterministic workflows and probabilistic, that's the trick in B2B. And the tipping point, it's not to say AI is not working, but it's your data which is not feeding the AI to make it work.
I think sometimes these are the hidden layers we all miss. We all are talking about models and agents, but we don't think the raw element of that is data. It's all there, but it's accessible, it's available in the right way, right format. I think Kalyan is giving the right tip to all of us. So let's start with our first theme-specific round, and that is on talent. How do we democratize talent in this whole AI ecosystem? So my question now to Gokul, first to you. What are the practical approaches which will help organizations to expand AI capability beyond some very small specialized team? Every organization we have few people who have figured out how to deal with data, how to create models, how to fine-tune models, how to put them into production, but majority of the people are just consumers of a ChatGPT. So how do you actually create that capability in the organizations that it is widespread in the organization and not just limited to few people?
This is an excellent point because it's easier to find AI skill set when you're coming fresh from college because they don't have to unlearn anything. But if you're already in the industry and you work for many years, there is a certain amount of reinventing that has to happen. One of the things that we actively look at is, at least in the semiconductor space, being a chip designers, we try to look at AI in engineering. If you're building products for AI, if you're doing compute and processors, we ourselves have to look at what it means to use it in engineering those products. Obviously, it's not an easy thing and it's not available yet and it's an evolving space. But more importantly, like you said, rather than it in staying in a pocket through an elitist, our goal is to make sure for each function, each role, and each capability in some way are having an exoskeleton of sorts. They walk into the campus when they badge in, they actually feel like they've brought in another assistant with them for what they're doing. And that is primarily by having them build or use an AI tool that will make their jobs faster, better, improved, either its efficiency or its quality. And when you have that, you have time to innovate. So that's another aspect that we've been looking at where everybody is actually having some kind of an exoskeleton capability with their AI assistant based on whatever role or function that they're doing.
And next question to you. We all are all charged up on the prospect of AI will change our lives, right? And we know AI can genuinely change our lives across the spectrum, in every field of life. But at the same time, because you are putting your data into a machine and machine becoming intelligent and giving results, we also have a lot of inherent, I would say, distrust. What is this black box which is giving answers? What type of data has gone into this? Is my data getting misused? So the question is, for a widespread adoption of AI, some of the fundamental questions will be transparency, explainability, And I think it will be not a matter of only a technology, it will always be a matter of regulation, also regulation and technology working together. So according to you, what all these elements of technology, regulation, observability, explainability are required, which will help build a wider confidence in AI adoption across the world, in India, everywhere? What's your take on this?
So humans don't trust black boxes, and we shouldn't, particularly for things that touch important parts of our lives. So I think you laid out exactly beautifully the components of the solution, right? One part is transparency. What data is a model being trained on? Is that data to be trusted, right? When we think about AI in education, we know we don't want AI education things trained on social media, because there's facts that we want our children trained on regarding history and culture, not just people's opinions, right? That's one good example. The second part truly is, to your point, understanding how the model arrived at the answer it did. So when we think about, for example, an AI model that's helping to identify how much purifier goes into a water system, right? There's been data over decades of what amount goes in after a flood, during a period of illness, right? And then there's norms of what there is. If a model is recommending something outside the norms, you're going to want even more understanding of why. And I think the final part of that is, exactly to your point, the ongoing training, so people feel like the model is also continuously adapting. The regulations are a really big piece of that, because when something's really important, the fundamental incentives of the private sector are advancement and innovation, not safety, security, and reliability. Regulation will help us do that. How we ensure it's not compliance checkbox, but rather really continuously evolving with benchmarks and continuously responsive to ongoing attempts to say, is the model safe? Has it been hacked? How do we know the results are okay? Will be needed.
Thank you. And so Kalyan, next question to you. I think you coming from a software background are very, very familiar with this dichotomy which India faces. On one side we say India has got the largest skill and talent pool in the world, but at the same time we say we have the shortage of the skill talent. We say the same thing in the same breath, so many times. So according to you, in this AI driven world, how can industry and academia work hand to hand to really make the talent available in a widespread way so that we can really benefit from AI, which it really deserves? So how do industry and academia work together?
So, see, if you really roll the clock back, we really were good at fulfilling demand. So if you look at the 90s, like India was always a demand fulfilling entity. So like when NIIT and Aptech, and they really created those stuff. Then when the big large IT services companies, they had to really build mini universities to really train people. I think Anne was pointing to the point that there's enough knowledge available now, correct? These systems have gathered, they have read enough. It's like you don't need to search for, they understand context. I would say looking at someone with a computer science background to solve all problems versus using that plus skill, the dual skill is going to become very, very important. Learn, unlearn, and relearn is something which each individuals have to take it on their own. You can't expect government and enterprises and others to only solve the problem. People also have to take, and I think with the availability of MOOC and other aspects, there's enough available. I don't think we have an issue of content. It's about how people adapt and use it.
Yeah. Okay. So let's move to the next theme now, which is the theme of data. I'm just hoping that I'm able to complete all the themes considering the time, but again, let's try to do as much as we can. So coming to the theme of data, and let me start with you. AI by nature means that you are creating a huge cluster of machines, GPUs, putting unlimited amount of data there, and the machine become intelligent, start giving data. So basically, you are concentrating data and resources in one place, and then you will start serving the whole world. That is one part of AI. But the second part of AI is, because you are putting your critical confidential data, every country says, I want to be sovereign and completely self-governed and independent to this. This is the dichotomy again, right? So ultimately, it will require a collaboration between countries so that these capabilities of each country can be utilized and everybody is able to benefit from AI in a collaborative way. Considering that technology and these tools are being used more like weapons of geopolitical negotiations nowadays, according to you, how can countries collaborate meaningfully so that the benefit of AI actually reaches the masses and every country is able to bring their capability forward?
I think it's a really excellent question. And I think the key will need to be federated data learning, right? So if we think about drug discovery and the ability to generate proteins that are not known to nature, right, using models, ideally you want to be able to test those drugs or identify on pretty much rare cancers, for example, just picking an example, right, where you have people around the world where you want to bring together that data, but you also understand that health data, some of the most sensitive data a country has. It has to be protected, and it's very reasonable for countries to expect that data stays local. So in the United States, we did pilot approaches during our Department of Health and Human Services with others around the world to say, can we train models where data stays where it is? And that's possible. And I think it'll be particularly important for data loads that countries are sensitive about, either from a national security perspective or a privacy perspective. So make the tech work in order to ensure that we protect what's most important, which is the core essence of the sensitivity of that data.
Okay. Kalyan, what I will do is I'll combine two questions into one, and I'll cover the theme of data and infrastructure both. You touched upon the point of data already in your previous answer, but let me repeat. What are the foundational data architecture shifts are required for organizations to truly become AI ready? You touched upon that, but I would like you to talk about that again. And my second question relating to infrastructure is, ultimately you'll have to do lots of partnerships across the ecosystem with multiple people. How do that partnerships play a role in building a scalable AI infrastructure? So two questions in one, please.
Cool. The first one, just I want to summarize on 3 key points on data. You have to start to imagine data as a data product. So data as its own independent entity. So if you're an enterprise, start with data catalogs. Do metadata discovery. You can use techniques like knowledge graph to really understand how data is flowing within the enterprise. You think data flows the way you designed. Reality on the ground, the data flows very differently. And many a times that understanding of the data, and every time you want to centralize, it explodes. Yep. It goes to the edge. Yep. So centralization is a dream, but it's never going to happen in the reality. I can quote the former Intel CEO, and I was always a big fan of Pat, and he used to tell me about these 3 things: laws of physics, laws of economics, and laws of the land. And that really drives, if you look at the data plate, sometimes just latency, you don't want data to be centralized. There is economics, cost, I think, and that's a big, big play. And the third is data sovereignty, residency. The second is lineage, governance, data tracking, data observability, because it's becoming very, very important. What you teach is how the system behaves. What you feed determines how the systems start to behave, and they learn. And there is hardly, I think there's some enough research people around here who will say it's very hard to explain how these systems work. Even the creators of the systems are not sure of how the interworkings of how these systems learn, because there's a lot of, it's become so multi-layered neural networks. They are learning very, very differently. So hence it's very important that you look at the input and the output, and you keep looking at the veracity of what's happening. And the third is build for real world constraints. And that's good. On the infrastructure, the reason AI is not new, it's been there for 50 years. What's happened is access to hyperscale compute has created more data, which now you need more compute to process. It's a very interesting cycle which we are creating. And energy is going to be a big play. In your world, you're trying to solve this problem, right? But you think you're solving the problem, but every time you try to attack it, you realize that you've not even scratched the surface.
That's true.
So that's going to be the big, big place. And that's where I think pragmatic use. Please don't use LLMs as a search engine alternative. I'll tell you, people are now using this public language models, and you're going to burn like half a liter of kerosene for every query, correct? You want to build small language models, you want to optimize infrastructure. So you cannot solve the infrastructure problem independent of the data problem. You have to think of them more holistically. So I would say we all need to become more judicious. So the FinOps discipline, which we had in cloud, needs to come in data and compute. They have to start to understand why am I using and what, and can I optimize?
Yeah. Fantastic, great insight. So Gokul, again, 2 questions to you, 2 into 1. The theme of infrastructure, theme of data, and theme of capital all into one. My first question is, how important it is at a system level, AI system level, to bake trust and governance into the stack itself by design, right even at the hardware level, right? You present hardware industry, so I'm asking how it's to be done at a hardware level itself. And my second question is, which I think globally is obviously the controversial question, how do we make sure the benefits of AI does not remain restricted to filling the pockets of few organizations only globally, rather the benefits of AI reaches the masses across the world? So two questions into one technical question, one controversial broad-based question, please.
Sure. Thanks. Were you saying that for the last? I mean, 3 in 1. When you're looking at data, clearly all aspects that Kalyan mentioned totally holds good, and he talked about the security. So when we are actually architecting the processor, security is a security first mindset. You can't have security as the last checkpoint before you release your processor design. So when you have a security first mindset, some of the things that come into mind is, obviously the most cliche thing is to say, hey, protect my data, protect my model, make sure that doesn't get hacked, but it's also protect the user. So there is 3 aspects. So there is application isolation, so that you can give a trusted environment where the application can run. Then there is an isolation with more growing usage of AI, where virtual machines have to be in a trusted environment beyond just the application. Then the third part is, if I'm going to connect multiple compute processors, that connect has to also be secure. So there are technologies for that Intel has as SGX and TDX Connect, but going out of all the terminology, app isolation, virtual machine isolation, connecting different hardware pieces together, all of those have to be secure. And that doesn't end there. When you put all of them together, you start to get something more as a confidential computing or confidential AI. So that is, again, going back to summarize, security first mindset when you're actually architecting the chip has to come, rather than at the end as a checkbox. And obviously we've done that over the years, and it's not easily done. You have to have ethical hackers who are actually going to find these vulnerabilities ahead of time, and that's one of the reasons why Intel processors even today are the most secure, and we're able to actually find this and also share with the industry. The second part that you asked me was around how do you make sure that that this doesn't get, how do you democratize AI from a standpoint of a larger usage. One of the things that which we should also be very, despite all the challenges of how we got into this room and be sitting here, is the fact that the AI Impact Summit has brought one aspect is just the Indic language translation. Being able to take an English and can have that in all of our Indic languages. And if you have a student who wants to learn, and if majority of the content is in English, they're able to either translate as well as transcribe and make notes out of it in all of the languages, has actually broken that barrier. There are several themes in the AI Impact Summit. One of them is just the language barrier that's gone. Once that is gone, I think there is tremendous amount of opportunity where you've already gone a big step in terms of democratizing. The second one is just leapfrogging in those domains where technology has not really broken in. That equity hasn't come. It's still in certain pockets where we use technology, but not everywhere. Agriculture, micro-entrepreneur.
Yep.
Maybe even in education, as much as we say there is technology, there are still so many of these schools that can benefit from it. We're still talking about 245 million students in India. That's almost the population of the United States, right?
Yep.
That many students. But if you take the ratio of a PC to a student, every 100 student has only one. I'm not saying you need to have a PC, but a compute device is fundamental to learning. It doesn't matter whether you're in engineering or in any of your professional degrees, even for humanities. That's what the National Education Policy talks about. I think things like that are really going to make the capital democratization far more powerful than any infrastructure can do.
Thank you. I think we can go on and on. These are the subjects which can go anywhere, but I have been constantly being threatened from the side that I am taking too much of time. So we will have to end this great panel here. I am just hoping you all enjoyed the session and you have some takeaways from this panel. Thank you so much.